All right, we're starting the second part of Unit 2. This is Unit 2, Day 1, Part 1, or Day 4, Part 1. Double trig functions, or you could think of them as composite trig functions. We're finding trig ratios of inverse trig functions today, which I think is the easier part of this section. So, what are functions of inverse functions? Here's an example. It looks kind of unwieldy and scary, but it's really just a composite function. So we had functions f of g of 3. This is a composite function. We knew to work from the inside out. We would find g of 3, get that answer, replace this with, so let's say g of 3 was 10, then we would then find f of 10. So this is exactly the same kind of concept. We're going to find the inverse tangent of this ratio first, and then we're going to find the cosine using the answer. So inverse functions return an angle, but what we're going to get out of these basically is not so much the angle, but we're going to get the triangle and the quadrant that we need to use to find the trig ratio. The angle is kind of just an interesting piece of information, but you don't necessarily use it to answer the problem so much, not specifically the angle. And remember, with these double trig functions, you're going to want to check the answer that you get with the type of function. So we're working from the inside out. So if you look at the outside function, remember regular trig functions, they return ratios. Inverse trig functions return angles. So on this one, you're looking at the outermost function. We should get a ratio at the end. If we don't, then we have not completed this properly. All right, so if we have this as an example, how are we going to solve it? First, we're going to basically pretend that doesn't exist and just solve the problem inverse tangent of x. So you're going to find the inverse tangent of some ratio. We are only going to be finding the principal value. So we're going to find the quadrant where the principal value is. Basically, we're not looking at the principal value angle, we're looking at the principal value quadrant. And then we're going to use that quadrant and that ratio of sides to draw the triangle in the quadrant and find the final answer. All right, so here's the example I'm going to do. Inverse cosine of negative square root of 3 over 2. So I'm going to be doing this problem pretending the sine part is not there. And we know how to do this. Cosine is adjacent over hypotenuse, so that means we have a triangle that has an adjacent of square root of 3, hypotenuse of 2. We should know by now that's 30 degrees. So but we have a negative. So what quadrant principal value does the negative ratio come from for cosine? It comes from quadrant 2. So we want to draw our triangle for 30 degrees in quadrant 2. And once we have this, now we're done with this first part, and we're going to move on to the second part. What is the sine of this triangle? Well, we know that sine is opposite over hypotenuse, so it's going to be 1/2. So we didn't really use the angle much. We found the reference angle, but we didn't use the final angle. Here would be 150 degrees. But we don't even care so much about that. Once we know the reference angle and we know the quadrant, then we can write the sides of the triangle, or the ratio of sides, properly and find our final answer. All right, so one for you to try. Inverse sine of 1/2, or cosine of the inverse sine of 1/2. So again, work from the inside out and see if you can answer that question. Check your answer in class. All right, so now we're going to move away from special triangles. We're still working on these types of double trig functions, but they're going to be a little bit differently. Find the value in standard position initial side in Q1. That's how they're worded. It just means it's a standard trig triangle. And so in this case, we have sine of inverse secant of negative 13 over 12. You'll probably notice right away this is not a special triangle, but we're going to sort of solve it the same way. We have, in this case, we have our hypotenuse and adjacent, and we're going to find our missing side using Pythagorean theorem. So start with secant, that's the ratio we have. It's hypotenuse over adjacent, so that means our hypotenuse is 13 and our adjacent negative 12. We know that because hypotenuse is never negative. Now we're going to use Pythagorean theorem. So it's going to be, remember, it's a squared plus b squared equals c squared, so be careful. That means we're going to subtract the square of negative 12 from 13 squared. It's going to give us 169 minus 144, or the square root of 25, or 5 as our answer. So now we know that our opposite is 5. And since we have a negative adjacent, I put the triangle in quadrant 2. Doesn't really matter where it is as long as you make sure that your sides have the right sign. And now that we have a triangle with all our ratios, or all our sides labeled, we're done with the inner part, which is this part, and we're going to find the sine of this triangle, which is opposite over hypotenuse, which is 5 over 13. So it's done really the same way. You're just building a triangle and then taking the ratio of sides. Another example, sine of inverse cotangent of 2. So again, start from the inside. Cotangent is going to be adjacent over opposite. Since we don't have a denominator, we're going to put this over 1. So we have adjacent is 2, opposite is 1. We need to find our hypotenuse this time. So it is a squared plus b squared equals c squared, so we'll take the square root of 2 squared plus 1, which gives us the square root of 5, so that's our hypotenuse. And now we're done with this part because we have our triangle. Now we're going to find the sine of that triangle. Sine is opposite over hypotenuse, 1 over square root of 5, which of course we rationalize. Square root of 5 over 5 is going to be our final answer. All right, I think I have one for you to try. If I can move this up. It's not being cooperative. Yeah, so you should try this one, work through and make sure you get the right answer. And then the homework is going to be the worksheet, these problems, because the worksheet has all of double trig function problems on here. So it's 1 through 6 and 13 through 18. Next time we will look at the other type of double trig functions. Bring your questions to class.